Okay, we're going to look at linear equations, and we're going to find points of intersection between them. So, because we have two linear equations, okay, so here's our Cartesian plane. One line's going to do this, another one's going to do that, and this is what we're looking for, the point where they intersect each other. They've given it both of the equations in standard form, okay, so we're going to number them. So our equation 1 and equation 2. It'll actually be easier had they given it to us in slope y-intercept form. So what we're going to do is we're going to put both of them into slope y-intercept form and then talk about how that will help us, okay? So to put it in slope y-intercept form, the goal will be to isolate for y in both of the equations. So in equation 1, let's get our color here, I need to move this term to the other side of the equation. So it becomes negative 2y is equal to 3x minus 10, right? The goal is still, I need it to be yellow here. The goal is still to isolate for y. So because this is times negative 2y, what we're going to do is we're going to divide every side by that. So we'll divide this by that, and this by that, okay? So when we do this, these two cancel out, and we get y equals, and I'm just going to leave this as a fraction, 3 over negative 2, or negative 3 over 2x. And this actually becomes positive 5. Well, that worked out nicely. Okay, and this is a negative term, so it's a negative slope. Okay, so now it's in point slope, or slope y-intercept form. Great. Same thing on this side. So we move our negative 4 to the other side of the equation. And when we do that, it will become 4y is equal to 5x plus 3. You're okay with that? Mm-hmm. Okay. Same process as before. We need to isolate for just the y, so we're going to divide everything by that 4, and these guys cancel out. So we're left with y equals 5 over 4x plus 3 over 4. So I got a bunch of fractions. It kind of makes it a little more difficult to work with stuff, but not the end of the world. So what we've discovered here, and this is still technically equation 1 and equation 2, they're just in different forms. These are in our slope y-intercept form. What they've told us is that y, or apparently y is equal to this in equation 1, and y is equal to this in equation 2. Well, we're going to use something called substitution. Since y is equal to that, I'm going to replace this y with this, I missed it there, with this whole equation. Okay, so this y is going to disappear, and I'm going to replace it with all of this. So there'll be no y's left, okay? Maybe with a highlighter that'll make a little more sense. So we're going to take this y value, and we're going to replace this y value over here with all of this. And we could have technically done it the other way. It'll look the exact same. So oops, that's not what we wanted. We'll write it in green here. So that, or actually that's the color we're working with. So I'm going to write 5 over 4x plus 3 over 4. Can you read this kind of? We'll change the black in a second. Okay, so we replaced y with this is equal to negative 3 over 2x plus 5. And what I'm going to do is just rewrite it all in black so it's a little easier to look at now. So we have 5 over 4x plus 3 over 4 is equal to negative 3 over 2x plus 5. So what we've done is we've kind of isolated the equation a little because we only have an x left. So the goal will be to isolate for x. So we got to get all of our like terms together. So I want all of my x terms on the left. So this guy's already on the left. I'm going to move him over. When I move him over, I'll get 5 over 4x. And this will become positive, plus 3 over 2x, okay? In that same breath, so normally they do some many steps, I want all my constant terms on the right. So this is a constant term. I'm going to move it to the other side. Now remember, this term has already been moved, so we have 5, and this will become minus 3 over 4. Did those steps make sense? Okay? So we got our like terms. We just got to simplify them. So these are some fraction rules, and I'm going to quickly do the fraction rules. If you don't remember them, kind of go over your stuff. But I need the denominators to be the same. So in order to do that, I got to multiply this by 2 and this by 2, which is going to give me 4 and 6. And when I add them, the denominator stays the same, so it's going to be over 4, and it's going to be 5 plus 6, so I'm going to have 11 over 4x, okay? Got to go through your fraction stuff if you don't remember that. This one here, I need to put it over 4, and it's technically over 1, so I multiply this by 4, that'll give me 4, this gives me 20. Denominator will be over 4. Ooh, that worked out good. 20 minus 3 is 17. So 17 over 4. Okay? Like I said, it's not really nice numbers we're working with. The goal is to get x by itself. Highlight our x here. We need to get x by itself. So because this is times 11 over 4, over here we need to divide by 11 over 4. Okay? So in order to move this, we're going to divide by 11 over 4. So tough numbers. When you divide fractions, so I'll quickly go over it on the side again, dividing fractions. It actually just becomes a multiplication question, and you invert the other side, so 4, 11. You can kind of reduce fractions by doing this, so it becomes 1, so you're going to end up with 17 over 11. So we get x is equal to 17 over 11, which is some number. But what's really important is this is actually a coordinate. Let's go back up here. X is 17 over 11. So if you took a calculator out, I don't like working in decimals, so that's why I did it that way, but 17 divided by 11 is this. So you would have got that number, 1.545454y4. And that's probably easier for graphing, 1.54-ish, okay? Well, when we solve for x, we found the x-coordinate of intersection. So what we're saying is we have our two lines, and then they cross, and at that coordinate, the x value is 1.54. We need to find the y-coordinate. And in order to do that, we do substitution again. We got to take this value and plug it into one of these two equations, either equation 1 or equation 2. We're going to replace x with it and solve for y. So I'm going to quickly take this one, y equals negative 3 over 2x plus 5. Y equals negative 3 over 2x plus 5. Again, I always work in fractions, which I know is kind of difficult sometimes. But this is that substitution step. It's the same idea. X is apparently equal to that, so I'm going to replace x with that value. Okay? In the other one, we replaced x with or y with an entire equation. This one, we have just a number, so we replace it with just that number. So we get y equals negative 3 over 2 times 17 over 11 plus 5. I got to use my fraction rules. When I multiply, top by the top, bottom by the bottom, this will be y equals negative 51 over 22, I believe, plus 5. Again, because it's fractions, these are really nasty numbers. I'm going to quickly do this. 22 is going to give me 10, 11, so I have 110 minus 51 is, if that was 50, it'd be 60, 59. Negative 59 over 22. Again, brutal number in terms of fraction, because I don't really know what it means, but I'll turn it into a decimal so the coordinate makes sense. And remember, the fraction part, it's not really important. It was just all that substituting. So negative 59 divided by 22, negative 2.68. So I jump back up here. I want to write it in. Negative 2.68. That's the y coordinate, which doesn't really make sense because it's a negative. I wrote it. Clearly, I didn't preempt this very well. That means this axis. Shoot. Let's kind of do this just so it makes a little more sense. The x-axis should be way up here. Okay? So the x value where they intersect each other is 1.54, and the y value is at negative 2.68. Tons of work.